Hello, can you hear me, students? What's happening? How are you guys? All good? Enjoying Tech Fix? What is it? Tech Max, sorry. Do you have any role in that? Are you participating? Audience, okay. Good audience is really important as well. Mm, yes. Okay. Good afternoon, guys. Welcome to the fifth day of GAN course, Next Gen Supply Chains, Harnessing IoT, Digital Twins, and AI-driven simulation. I hope you have been enjoying this course. In today's session, we are going to discuss the case studies using optimization and simulation techniques. Yesterday we talked about what are the optimization techniques, what are the simulation techniques, what is the difference between optimization and simulation techniques. We also looked at the how to formulate the mathematical model and how to solve those mathematical models using your linear programming graphical method. Okay, so do you know how to solve that mathematical model in Excel form? I know you know, nowadays everybody does coding in the Python and you get the results, but do you know you can solve that model in the Excel solver as well? Have you tried that? Because I have got the the Excel file as well. If you want to show, I can show you how to do that as well. No? Okay. Okay, that's fine then. So let's do the our quick reflection on what we discussed yesterday. Our menti.com quiz. Go to this menti.com, scan the QR code, and then we'll see what do you know about optimization and simulation. Let me see. You can use the the code as well. Suppose the QR code is not working, you can go to the menti.com, enter the code, and then you join the presentation. First question: Finding the best solution from all feasible solution is called simulation, optimization, modeling. Sometimes students they get confused between modeling, optimization, simulation. So that's why this question, finding the best optimum solution from all feasible solution. Feasible solution means solutions that satisfy all constraints. What comes to your mind when you hear supply chain optimization? Optimizing what? Fast delivery, better communication. Okay. Maintaining chain profit. Yes. Best outcome, optimizing all processes, best solution in supply chain, utilization of resources. Yeah, because when you try to optimize something, so at that time we consider the resources as well, restrictions, constraints. Yesterday I gave one example. Suppose if you want to go from Varanasi to Delhi, okay, you want to go, but what are your constraints? Money constraint, you have got only 1000 rupees. Time constraint is there, you have got the luggage as well. So your objective is to reach to Delhi, but given that you need to satisfy all those constraints, you cannot violate those constraints. So that's your supply chain optimization, basically finding out the best solution. That can be maximization of your profit, minimization of cost, minimization of lead time, minimization of something. And when you come to the maximization, sometimes you focus on the customer satisfaction level, you need to maximize that satisfaction level. Social objective as well, when you see the three dimensions of sustainability. Economic, you try to maximize the profit. Environment, what do you do for environmental? Do you maximize or minimize? What do you minimize there? CO2 emission. Okay. And then in societal dimension, what do you maximize, minimize? What do you do? Hmm? What do you minimize the societal impact? What do you maximize? Tell me some examples of what comes basically in societal dimension. Job opportunities. Okay, what else? CSR, corporate social responsibility. But what is that CSR? We just see, okay, CSR is there, but what does it mean? CSR, corporate social responsibility. They need to contribute towards the societal goods, societal cause. Okay. Yeah, job created is one. Anything else? Logistics, what could happen when you drive the vehicle? How does it affect the public? The health, the pollution that you are creating, it will affect the public health. If something happen, accident, the people may lose their lives. Societal, workers who are working in the factory, if something happen unexpected, if they lose their lives, what could happen? That is a societal impact. So when you try to maximize this societal impact, means you try to minimize these the negative impacts, whatever the public health problem, because of air pollution, water pollution, and because of these working conditions. So that's your societal dimension. Which of the following method is used to visualize the behavior of the system under given set of condition? Optimization, transportation, network modeling, or simulation? Simulation is the correct answer, because we model the simulation, we model the supply chain network with the help of simulations to find out or to study the behavior of that system under given set of conditions. If you want to see the dynamic nature of that system, then only we go for the simulation. What is the key purpose of simulation? Reducing labor cost, eliminating uncertainty, predicting future trends, or replacing optimization methods? Okay, good. 2. Yeah, good mixture of answers. Eliminating uncertainty completely, predicting future trends. How could we eliminate the uncertainty completely? Tell me. Yesterday we talked about the system. What is system basically? System has two kinds of inputs. What are those two inputs? Any system, suppose if you consider hospital as a system or bank as a system, what are the some known inputs in that? Suppose you are running a restaurant, what are the some two kinds of inputs? Sorry, people and process. Okay, and you last? Labor. Okay, yesterday I have shown you one diagram: system, controllable inputs, and then uncertain parameters. So if you take the example of restaurant or bank, what are the known parameters there? Input, tell me. In that bank, in that restaurant, you know how many tables are there, how many servers are there. Then what are the uncertain parameters? Arrival rate or the demand, we don't know. Okay, so for that purpose we use the simulations to find out what will be the my profit, given that whatever the you predict the forecast for your demand, and you use that simulation to analyze that system. And how do you eliminate the uncertainty here? Then tell me, can we eliminate the uncertainty in simulation? No, uncertainty is involved, that's why we would go for the simulation. If there is no uncertainty, you can go with the optimization method, because everything you know, use that input and then optimize the network. Whenever the some uncertainty comes, then only you go for the simulation, you predict the future, you predict the forecast. So that's why. But nowadays what is happening, simulation and optimization hybrid methods are also coming, so for optimization they are using some part of optimization simulation, then they are doing in simulation they are using little bit optimization. Those kind of hybrid techniques are also appeared in the literature. Simulation should not be applied in all cases because of what? It requires considerable talent for model building and consider computer programming efforts, consumes much computer time, provides at best approximate solution to the problem. Yesterday's model we were running for 1 year, am I right? If you want to build that model from a practical situation, how much time do you need? What do you think? Yeah, why? Because you are running the, yeah, you are running that model for 1 year, means you are trying to understand the behavior of that system 1 year. Suppose if you want to observe the system, say example bank, hospital, you cannot go there and just stand there 1 hour and see how many people are coming and how many people are going. You cannot do that in 1 hour. You can't understand that system totally. Okay, so you need to spend a good amount of time. You need to see when the peak is there, when the customers that arrival will vary, when the departure rate varies, what is the utilization rate of your counters, tailors, all those things. So that's why it needs huge amount of time. Again, talent for model building. If you miss any characteristics of your real world system, your simulation model will not give you the exact answers, whatever the answers you are expecting. That's the one. And it's another one, it provides best approximate solution. Like in optimization, you get, when you solve the model, you get the one optimal solution. But here in simulation, it would provide you the couple of options, what if scenarios. Okay, because why? Because our input is uncertain. Input is uncertain, so that it will provide the solution. Like, given that if your demand is 500, this is the solution. If your demand is 600, this is the solution. So this kind of couple of what if scenarios model will give you. So it will not tell you this is the final answer for your problem. So the correct answer is all of the above. Simulation is an optimization technique, obviously. Simulation is an optimization technique. As I said, It is not an basically optimization technique, but nowadays some hybrid techniques are I know are there. You can use those techniques to to optimize with the help of simulation as well. But basically the main purpose of the or the fundamental purpose of your simulation is to understand the complex system, which you cannot understand or analyze using your optimization methods. Okay, so yesterday I gave one example. Suppose in your bank there is only one counter is there and only one lane is there, and if I ask you, can you use your some queuing theory analysis and tell me what is the utilization of that counter, what is ideal time, what is the queue length? You can do normal calculation. MM1 MM1 means the arrival rate is exponential, then departure rate, and then one counter is there. You can use those simple formulas, okay, and then you can find out that. But what happens if you take the example of airport? You have got multiple counters, 20, 30, 40 counters are there. How many lines are there, we don't know. Can you do the manual calculation there? No, you cannot use the optimization there. Then what do you need? First you need to understand the system there, and to understand the systems you need the simulation, some computer model. So that's the why simulation basically it is not an optimization techniques. Simulation it is basically to understand your system under given set of condition, under given set of whatever the time you want to analyze. Simulation provides exact answer, approximate, optimal answer, all of the above. Approximate, as I said, it doesn't provide you the optimal solution. Like when you solve your mathematical model, single objective model in Python, in Cplex, Gurubi, Lingo, whatever the tool, you get one solution. Like in our that just shirt example, when we solve that model, the profit was 700 rupees. The decision variables 60, 50 were the decision variables. Okay, so when you use any other methods, the answer will be same. You will get the same answer. So, but simulation it provides the approximate solution because of the uncertain nature of the inputs. Simulation it does not solve problems, it provides only quantitative measure to solutions. Do you think that when you solve the model, simulation model, you can your problem will be solved? What do you think? True, it doesn't solve your problem. Like in optimization it will solve the problem, it will give you the decision variables values, how much quantity you want to transfer from one location to another location. But here in simulation it will give you the only the couple of options, and then as per your requirements, as per the decision makers preferences, you select the response. Simulation methods are easier to apply than the analytical methods. What do you think? True, false? So you have got one mathematical model and you have got the simulation model. Which is easier? Mathematical model is easier. Simulation methods are easier. Like in our any logistics tool, you don't need to code anything. Just drag and drop option, define the parameters, and at the back end they have got all the whatever the solvers are there. K-means algorithm is there. Cplex, branch and bound algorithms are there. Okay, so if you want to find out that mathematical model as well and what formula they are using, if you look at their book, any logistics, they have got the full book. So in that book they have given the formulas as well, what how they calculate the transportation cost, how they calculate the inventory cost, everything like economic order quantity, reorder quantity, safety stock, everything they have got the formulas behind each and every table. So you can refer that book and they have given all the information. It's not like blindly they are doing this calculation. So for each and everything they have got some references. Simulation is more difficult than optimization for decision makers to understand. Decision makers means, suppose you are I gave one example yesterday. facility location. Suppose your top management, they want to open new factory. Okay, so which one do you prefer, optimization or simulation? Sorry, it's false. Simulation is more, it is easier for the decision makers. Okay, uh, two examples. Suppose if you model that mathematical model in Python programming, and you go there and say, this is my Python program for our optimization problem, do you think that they will understand it? No. And if you make this kind of some dashboard or some model, they can very easily analyze, okay, these are our suppliers, the products are going from one point to another point, and then they can do their data driven decision making. So this is the end of our quiz. Now let's move back to our slide deck. Okay, so the learning objectives of today's session is to couple of our objectives are there. Formulate and solve an optimization model for a real world case. So yesterday we saw formulated that gestured example. Now and I hope you know how to solve that model in the Excel as well using solver, because in Excel we have got the solver. You can solve the linear non-linear problem in the Excel solver. Use Excel solver as you know that one, so I will skip the Excel solver part, and we will focus on the any logistics, how to model the problem in any logistics, and how to do the optimization, network optimization in any logistics, apply optimization techniques, and then apply supply chain performance using simulation. Yesterday I think Aman and a couple of other students, they wanted to see the bigger problems, multiple countries, and how the goods are moving from one country to another country, and what kind of parameters do you need. So we will look at that as well. So please open your any logistics software. So because today we are going to do the from the scratch. I am not going to give you the Excel file to directly import it. Okay, I want you to do exactly what I am doing. So supply chain design and network optimization. What is supply chain design, guys? What is the difference between supply chain design or network optimization or facility location? What are the some of the common problems in supply chain and logistics? This is called supply chain design. What do you mean by supply chain design? What do you do in supply chain design? Okay. Oh, locating the facilities. What else? Do you do anything else apart from locating facilities, or do you only locate the facilities and then you leave that? Okay, you locate the facility, transportation. What else? You find out the inventory. Supply chain design means you are designing the whole supply chain for that product, whatever product. Who are your suppliers, where are the suppliers located, how the suppliers are connected to the manufacturers, where you want to open the manufacturing plants, manufacturing facilities, and then how much quantity you want to make into that manufacturing plant, and then how much stock you want to keep, then from that manufacturer how you want to move the goods to the distributors, or do you want to keep any one direct route directly to the retailer or customers, because sometimes companies, they have this kind of direct routes as well, so they bypass the distributor retailers and they directly send the products to the customers. Okay, so then supply chain design, basically it covers locating the facilities, defines the locations analysis framework, selecting the source, production and storage facility, which are your suppliers, where are they located, where you want to manufacture the products, and where you want to keep those finished products. It ensures the connection between these facilities. Okay, so sometimes what do you do in the vehicle routing problem? Any idea? What is vehicle routing problem? What is traveling salesman problem? Hmm. Return back to the demo, so depot. Okay, and what is TSP? Hmm. Hmm. In TSP, do you need to come back to the original point? Okay, So what are the some new variants of VRP or TSP? Do you know? New new variants in that problem, vehicle routing problem where trucks are there, fleet of vehicles, and the drones are also there. So the at one point vehicles will stop, and then the drone will pick up the products, and then they will do the last mile delivery. So those kind of advanced variants are in vehicle routing problems, trucks plus drones, so many other things are there. So key goal of supply chain design is to balance the cost effectiveness with the service level requirement. So you want to minimize the cost. When you say the cost means not the only transportation cost, facility location cost, transportation cost, inventory cost, and you want to satisfy the customer demand as well with the 100% service level. So network optimization, it aims basically in management terms, it aims to find the most efficient combination of factories and distribution center. Network means we normally focus on the factories and distribution centers. Due to the high number of possible configuration, mathematical model assist in decision making. So mathematical formulation, for example, of the supply chain network design, you have got the potential locations like Germany, Frankfurt, UK, potential facility locations. Then you have got the market demand as well. So you got the in yesterday's example, we had the 10 customers, and we had the 2 potential locations as well. So market demand, then potential facility location. You need the transport links as well. How do I not transfer the products from your that potential locations to the facility? It represents all possible warehouse to market connections. What are the cost components? When you open the facility location cost is there, is open in region, annual fixed cost is incurred. Then annual transportation cost, once you make the products in that factory, then you need to move those products to the distribution center, warehouse, customers. So that transportation cost will come there. So objective is to minimize this total cost, okay, by selecting the optimal combination of facilities and transportation links. Any doubts, guys? Hello, any doubts? Okay. Solve an incapacitated network optimizer. What is capacitated and incapacitated problem, guys? What is incapacitated, capacitated, facility location, or network optimization? Yeah, go on. Hmm. Capacity, okay. Okay, so that is about your transportation. But yeah, I am saying capacitated facility location problem. What does it mean? Capacitated facility location problem or capacitated VRP. So what you said, capacitated VRP. So whatever the capacity of the vehicle, that should not exceed beyond the whatever the demand is. We cannot go more than that one. Yeah, that's the your vehicle routing problem, capacitated. But what is capacitated facility location problem? Yes, so that's the same logic. So when you say the capacitated location problem, whatever the facility you are trying to open, either it could be the your manufacturing plant or distribution center. So whatever the capacity you are trying to define there, so the storage and the inventory level, it should not go beyond that your capacity. So that's the one. But in yesterday's example, I have shown you, the capacity was 0. Why? Because we were not restricting that capacity level. But if suppose I want to say that my capacity should be 100 meter cubic of that warehouse, then you can put that restriction. That is called capacitated facility location problem. You can use the same logic for your VRP as well, capacitated vehicle routing problem. This approach ensures an optimized supply chain network, balancing cost and efficiency for efficient decision making. So this is an example. Suppose what normally in supply chain network design, okay, so we try to locate the facilities, and then we try to minimize the transportation cost, inventory cost from one location to another location. So you can see one general the formulation here. Can you tell me what are the components of this first objective function? Any idea? First is the opening facility. What is this term? What could be this F of S? Factory opening cost, fixed cost to open that. F of S. What is this Y of S? Any idea? Not decision variable. What kind of decision variable? Binary, 0 or 1. Okay. What is next? Second term? Transportation cost from supplier to market. And what is this second one? X of SM? Binary or integer? What do you think? Binary or integer? Good one, yeah. So again, both Y of S and X of SM, these are the binary variables. So first one is, if you are locating a facility, so wherever you are locating facility, that variable will become 1, and then that facility cost will add into your objective function. The second is transportation cost from your supplier to the market. Again, this is a cost, this is a parameter, and this is a decision variable. Again, X of SM, this is your binary variable. Okay. So you are saying that again, if you are moving the goods from one warehouse, one supplier to the market, then only that cost will apply. If you are not moving the goods, the transportation cost will not come there. That's your objective function. What is this first constraint? Any guess? Any idea? X of SM summation over the supplier equal to 1 for all M. M means market. S means supplier. Only yes, market should get the products from only one supplier. That's the constraint that we are saying. Summation. Summation means whatever the suppliers are there, two suppliers should not, only one supply should go from one supplier to that market. So multi-supplier strategy is not there. Does it mean multi-supplier strategy is not there? If I want to add the multi-supplier, what should I do? What changes do I need to make here? Greater than equal to where? 1. Yes, the greater than equal to 1. What is the next constraint? Second one. X of SM less than equal to Y of SM for all supplier, for all market. Okay. Anyone else? What do you mean by facilities available? Hmm. 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 What happens, suppose if I remove this constraint? Does it make any difference in the model if I remove this constraint? What difference will make? So you are saying that first f of s ys will become 0. Hmm. Okay. Mm-hmm. Anyone else? Anyone would like to add anything? There is this constraint is very important. Why? Because we are considering the potential locations of your distribution center facilities. What does this constraint tells to us? If when can you move the goods from your supplier to the market? Supplier to market, when that facility, distribution center, whatever you are considering, it should be open first. Okay, it should be open first. If that facility is not open, how could you transfer the products from that location to the market? So in order to make sure that, what we are saying X of SM, this is a binary variable. So when it is less than equal to Y of S is the binary variable for facility location. When this Y of S become 1, become 1 means the facility is located, then only your x of sm will become 1 or 0, whatever it may be. But means x of sm, it depends on the y of s facility. Initially you locate the facility, then only you move the goods. Okay. Sometimes what happens in the mathematical model, if you remove these kind of constraints, then the model will move the goods from the any potential locations to any markets. So it will not consider whether the that facility is opened or not. Okay. So in order to make sure that your facility is open, we added that constraint there. So this is again binary non-negativity constraint, you can say binary variable constraints. Okay, so network optimization can be used for a number of supply chain design problems, incapacitated and capacitated plant locations. So just now I told you, capacitated means we are considering the capacity when you are locating. Suppose I am saying that I want to locate a factory in Varanasi. So I am saying that the production capacity of that factory should be 1000 products per day. That is capacitated. Incapacitated means I am not putting any restriction on that whatever the facility I am locating. Distribution network design, suppose if you want to find out how you want to distribute the networks from your manufacturer or a retailer, you can do that. Distribution network design with inventory, lead time, transportation mode selection. For that purpose as well you can use the network optimization. Suppose you want to move the goods from your distribution center to the retailers, and you have got 3 modes of transportation: rail, road freight, sea freight. Then what is your criteria? Normally time, we consider cost, so many factors are there. So you cannot totally rely on one single mode of transportation. So it depends on the customer's client's requirements, whether they want the what is the lead time. Suppose lead time is very short, you need to go with the air freight. So those kind of problems we could solve in the network optimization. Product distribution network design, hub location problem. Again, do you know hub spoke model? Any idea? Again, very famous and popular term, hub spoke model. Yesterday I talked about the cross docking. What is hub spoke model? Any idea? Hub and spoke? No. Okay. So basically hub and spoke model means, suppose these or whatever these big retailers you consider, Walmart, Amazon. So what they do, outside these metro cities, outskirt of that metro cities, any metro city, they set up a big warehouse, and the trucks, big lorries, trucks, they get the products from the suppliers, from the upstream members into that the small big warehouse, and then from that big warehouse, small delivery vans, they pick the products and they deliver within that your location within the city. That is called hub and spoke model. So that is your big hub, and then spoke means you are delivering to the your all the customers. Supply network design with the operational risk. Okay, so network optimization could be used for the your operational risk as well, modeling operational risk and modeling disruption risk. Any idea what is the difference between operational risk and disruption risks? Okay. Risks becomes because of uncertainty. Any risk, doesn't matter whether it is a operational risk or it is a disruption risk. Risk occurs because there is a uncertainty about the future events. Okay, what is uncertainty? Any idea? There is a difference between uncertainty and risk. I am going to cover these parts in detail in our another session, but just I am asking, any idea what is the difference between uncertainty and risk? What does mean by uncertainty? Uncertainty means randomness. We don't know everything about that event. Okay, suppose I say that tomorrow there will be a traffic delay here, there will be some earthquake, something gonna happen tomorrow. So is it uncertainty or certainty? How come? I'm telling with 100% certainty that this is gonna happen tomorrow. So that is certainty. Uncertainty, if I say that okay, tomorrow something may happen, traffic delay or something, earthquake, flooding, tsunami, something. So that is your uncertainty. And then what is risk? As I said, risk occurs because of your uncertainty. Okay, uncertainty means you can list down the potential events. You can list down tomorrow it may happen something blah 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 blah. You can list down, but can you tell me the its probability? You don't know which will exactly occur, and you don't know their probability. That is called uncertainty. And what is risk then? Risk means we know the potential events that may happen, and we know their probability as well. So it means that risk is a measurable term and uncertainty is not a measurable term. Okay, sometimes we use uncertainty and risk interchangeably, but there is a clear difference between uncertainty and risk. If you look at the academic books, reference books, or any academic papers, they have mentioned the clear gap between uncertainty and risk. So operational risk, regular risks, high frequency, low impact. What are some high frequency, low impact events? High frequency, high occurrence of those events, regularly occurring, machine failure, machine breakdown, delivery delay, regularly occurring, and the impact is lower, not a significant impact. So that's your operational. What is disruption? Low frequency, high impact. Any example? Earthquake, flooding, tsunami. We cannot predict when your earthquake will come. Okay, so low frequency, and it doesn't occur regularly as well. So that's your disruption risk. Supply chain design using network optimization, it considers the various parameters like alternative facility location, customers, markets, production, inventory processing, transportation cost, then again fixed facility cost, inventory holding cost. When we solve the model facility location problem using GFA, we didn't consider any facility location cost. Okay, when we converted that model in the simulation, then we added the facility location cost and processing cost. So minimum and maximum throughputs, capacities in production, transportation and storage, demand in the markets, number of periods and products, bill of materials. What is bill of material? Any idea? What is it? Yeah, that's correct. Invoice that contains all the information about the requirements for your finished product. Suppose I want to make this slide changer. Okay, so what are the components needed? How many batteries are there? Connector is there. So the invoice or the bill of material means the sheet containing all the the parts, components needed to make this port. To make this part, that's your bill of material. For what purpose do you need in this network optimization? What is the use of bill of material? Because if you are making something in production factory, you should know how much raw material component you are using to make that finished product. So that's the use of bill of materials in your network optimization. The variables to be optimized here, so we try to find out the locations, how many locations you want to make, what should be their capacity, quantities, flows to be delivered from sources to destination. The solutions are usually constrained by minimum and maximum and minimum demand in the markets, minimum and maximum throughputs means supply, and the objective function we try to minimize the total cost, or we try to maximize the profit. So this is a case study now. So Davis, CEO, Marina inventory manager, and Cheng transportation manager need to analyze the distribution network of their company. To begin, what they are going to do, they will use network optimization to compare alternative network facility combinations and paths. So in the existing case, in that company, they have got the 2 DCs and they have got around 6 customers. So they want to use the network optimization to check that whether this existing network is good for their company, or what would happen if you add additional DC, whether it would be good option or not. So they want to or they can remove any existing DC. So that they want to do, and then next Davis, Marina and Cheng will use simulation to analyze the KPIs, financial, customer and operational performance of the company's supply chain. Afterward, they will review their options for changing inventory control and transportation policies. What are the some inventory control policies? Yesterday we talked about EOQ. What else? Minimax. Then RQ policy. Then there was other policy as well, cross docking. Okay, and transportation policies means, what is transportation policies? What are the transportation policies? full truckload or less than truckload policy. So you have already got the slides. Okay, so now what you want to do, the data is given, everything is given. Their supply chain offers 3 products: PC, monitor and multifunctional printers. These are the three products. There are 2 customers for each product. 2 customers for each product. How many total customers or demand? 6. The customer demand is fixed at 50 units day. What is it? Which kind of this demand pattern? Fixed, deterministic, but what is it? Periodic demand. Every customer is ordering 50 units daily. The time interval is daily 1 and the unit quantity is 50. The supply chain is made of customers, 2 DCs and 1 supplier. So we have got 1 supplier, 2 distribution centers and then 2 customers. Their supply chain runs at 90% customer service level policy. The distribution centers for each product use the minimax policy. Inventory storage, they use the minimax policy. The minimum level is 57 units and the maximum level is 113. What does it mean? When the stock level reaches at 57 or below that, how much should they order? It's not fixed. They can order up to 113. It depends on what is the current level, but they can go to the maximum 130. So we cannot order the fixed quantity here. It varies. Subject to maximum storage area capacity for each product at each distribution center. The customer expect to receive their order within 2 days. What is this 2 days? Lead time. The lead time from the supplier to the distribution. So lead time from the distribution center to the customer. What is that lead time? 2 days. Then we have got the supplier as well. So what is the lead time from supplier to the distribution center? 0.7 days. And this lead time from the distribution center to the customer varies from 1.8 to 1.95 days. Basically, the 2 days the customer expect, that is the lead time given by the customer, 2 days. But if how much time company needs to transfer, it varies from 1.8 to 1.95 days, depending on the loading and unloading processes at the distribution center. Then what is the trucks with a 60 meter cubic capacity transport products from the supplier to the distribution center? And then lorries with capacity of 20 meter cubic transport products from the distribution center to the customers. And LTL shipments are used without minimum load restrictions and order aggregation. A direct shipment distribution network is used. LTL shipments without minimum load. What is that minimum load? LTL means we don't need to check the how much load available in that vehicle. As soon as they receive the order, they can move the goods from that DC to the customers. So this is the input data. So we have got the customers here. You can see Hanover, Munich, Vienna, Poznan, Hamburg and Nuremberg. So these are the 6 customers, and you can see their demand as well. Okay, latitude, longitudes are given. Transportation cost is also given, calculated 1 into volume into distance. There are 2 DCs, DC Prague and DC Berlin. You can see the latitude and longitude. What is this cap? Capacity of each DC. And these are the details of the product. So name, unit, pieces, selling price and cost. What else do you need? DC carrying cost. You are keeping the inventory at 2 DCs, so that's 0.01 USD meter cubic. Transport cost is product and distance based, 1 USD per meter cubic per kilometer. Processing time is triangular distribution, it follows the mini, max and mode. Okay, so DC Prague serves these 3 customers and Berlin serves these 3 customers. Okay, so because it for the any logistics, it is easy to convert the pieces into the meter cubic volume, because the capacity of our lorry is 60 meter cubic and truck capacity is 20 meter cubic. So but the units we have given for the each products is pieces, 1 piece, 2 piece. So we want to convert that pieces into the meter cubic so that it can follow that volumetric area for that truck when you calculate the transportation or number of vehicles used. So this is the vehicles details: truck, lorry, capacity, and the speed. And you can see the grouping as well here. And then this is the fixed location cost, facility location cost, 0.0 USD. This is the carrying cost. And this, what is this other cost? Facility location cost. Okay, so this is given for the DC Berlin. And can you see this? There are 3 DCs. Why 3 DCs? Because in existing network they have got only 2 DCs, but they are trying to analyze basically if we open the new DC in Poland, then whether it will be a good option, or we can basically remove any existing DC. That's why they are considering these new locations as well. So these are the customers. Now start from the scratch. Create the model. First create those 6 customers, 2 DCs and 1 supplier. Everything is available. Everything is given in the slides. Create this model in the network optimization. Don't go with this greenfield or simulation. So look at create scenario. I am saying create scenario. I am saying I want to create the network optimization. So day 5 I am saying NO. And what is this advanced setting? If you click on this advanced setting, suppose you want to ask any logistics to randomly select the customers based on the population. So you can see that you can select any country. Okay, suppose if you want to select the India, just I am saying suppose India. It is come. Okay, India. So and if you want to locate the suppose customers there, 100 customers based on the population, then you can say this 100 demand per citizen per period, order placement, number of products, number of sites means facility DC, and site carrying cost. When you create it, it will directly create the 100, 200 whatever customers with whatever the facilities are there, if you want to do that. Okay, but we don't want to do that. Why? Because we have got the input data. It is taking some time. Yes, we are running for 1 year. I don't know what happened to this PC, but I can see 2 screens here. Let me close it. I will see everybody's model. I want to see everybody's model. Okay, so don't try to import any Excel file. It's very easy. So normally what you do, you create the first 6 customers in Europe near to Germany, and then you go to the location table and update the latitude and longitude. If you have any doubts in input data, if you don't know anything, just ask me. Created the supplier distribution centers. Look at that third DC as well, DC in Poland. Hmm. Have you opened the third DC as well? Sorry. So you want the latitude and longitude of third DC. I will show you. I will give you the coordinates. Meanwhile, you can start adding other details, the demand, transportation cost, everything, whatever the data is given, define those parameters. So DC Prague and Berlin, what is the capacity? 100. Demand pattern is periodic, daily demand, and quantity is same. First day, sorry, this is daily 50. Then you can see down penalty and up penalty. Currency is there and USD. Any idea what is this down penalty, up penalty? Okay, reaching on time. If delayed delivery is there, that's why you are saying that penalty. Down penalty is there and up penalty is there. Is it correct, guys? What is the purpose of penalty in this demand table? What is the use of this penalty in demand table? Aman is saying that if delivery is delayed, that's why this penalty is given. How does it apply? Suppose if your delivery is delayed, then which penalty will apply? Down penalty or up penalty? Down penalty, because your delivery is delayed. What about up penalty? When you deliver the products well in advance, early, then you will get penalized. Yes. Okay. So basically the use of up penalty and down penalty. So what is the demand of each customer? 50 products daily. So if distribution center provides those exact quantity, that's fine. If this is a demand constraint, guys, this is a demand constraint. If suppose distribution center delivers the lower number of products, lower than the demand, then down penalty will apply. Where if suppose distribution center sends the more products, higher products, more number of products compared with your demand, then up penalty will apply. So in order to make sure that your model is feasible, that's why we are applying penalty here. It is not whether it is delayed or not, how much quantity you are delivering. Demand is 50. Suppose distribution center deliver the products to the Hanover, 45 products. The down penalty 5000 will start applying there. Okay. Up penalty, suppose distribution center delivers 55 products. Up penalty will come there. So that's the meaning of up penalty or down penalty. What will happen? Suppose I make both values 0. What will happen? No penalty. No penalty. Yeah, no penalty. And suppose I am not able to satisfy my the demand of my customers. Then in that case, you said the up penalty is 0, down penalty is 0. Then, and you don't have sufficient quantity. Does your model work there? No, it's non-feasible solution. So in order to make sure that in mathematical modeling we do it, in MATLAB coding or some other, when you code your constraints, you apply some penalty. Why? We say that suppose that constraint gets violated, this penalty will add and this penalty will come into your objective function. So that's the use of this penalty. Okay. So when you make the down penalty and up penalty 0, that is your hard constraint. And this is your soft constraint. Soft constraint means we are allowing the model to violate that constraint. The distribution center may send up more than that demand or lower than the customer's demand. But if it does, then this penalty will come there. If you make the penalty 0, and if suppose there is if you are not able to satisfy one customer's demand, then the whole model will not run. Suppose out of 6 you have satisfied the 5 customers demand and only one customer is left, now you don't have sufficient quantity, so it is good to get that loss and to run the whole network. Okay, that's why this penalty is there, up penalty and down penalty. So you wanted the coordinates of third DC. So these are the coordinates. Warsaw 52.24 and 21. Latitude is 52.24 and longitude is 21.006. These are the coordinates of your third DC located in Poland, Warsaw. So how many tables you have defined? Customers done, DCs and factories done. So you need to add the third DC here basically. Where is that DC? I am locating here Warsaw. Okay, and I am saying DC Warsaw. What is the longitude locations? I am going 52 point. Okay. Yes, 52.2. Yeah, so exactly I placed there. So don't worry, 52.25. Okay. So this DC Warsaw in Poland. The latitude is 52.24 and longitude is 21 point. Am I right? 21.006. This is your third DC. Can you see on the screen? Your third DC in Poland. Okay. So far what we did, we completed the customer table, DCs and factories done. We have got 3 DCs. Demand, have we defined the demand? Down penalty and up penalty keep as it is 5,000. Locations, 10 locations done. Objective members, somebody yesterday somebody was asking Aman or someone like how do you define the objective function. So here total revenue, so depending on your problem, so here we are calculating the profit, so revenue is come there. What is penalties? What is this penalties? Penalty that we are applying if the constraints get violated, so that penalty will come into your objective function. So total revenue minus your total penalties minus your total transportation cost, production cost. So here we can turn off this production cost as well. Why? Because we are not making any products in factory, we are only considering the distribution center. So you can turn off these whatever the objective function member you want to do it. So if you keep as it is, it will show the zero production cost, so it doesn't matter. Supply cost, initial cost, closing cost, carrying cost, inbound processing cost. We are considering only the outbound processing cost, we are not considering the inbound processing cost. CO2 emission, we are not considering tariffs, we are not considering any tariffs. Why there is no tariff here, guys? Why there are no tariffs in this example? When does tariffs will come into your model? out of the country. When you are moving out of the country, import export, that time here everything is in within the Europe. Okay, so Europe, when you move the goods within the Europe, you don't need to pay any tax. So that's why the tariffs are not included. Okay, so objective members done. Paths, how do I define the paths? But before that I need to group the customers. I need to make some groups. What is the purpose of groups? To make it simplify. So I am first I am making the groups of DCs. So how many DCs are there? 3. So I am making the group of those 3 DCs. Done. Then I am grouping the customers, DC Berlin's customers. DC Berlin's customers. DC Berlin. I am which are Hanover, Hamburg, and Poznan. Okay, so Hanover, Hamburg, and Poznan. I am going to come there and I am going to see your model now. I want to see each and every table what you have done. DC and there is another. I want to make it all customers. Venkat, done? Whole model? Can you see the connection? Can you see the connection here? No? No, if you don't create the group, then you need to individually connect this one, this DC to this. The benefit of grouping is that once you group those 3 customers, you can just in a one row you can connect this DC to all those 3 customers. Indicator constraints, linear ranges, location groups done. Groups, locations, objective member, paths. Okay, so paths. How do I define the paths? How do I define the paths? From where? Supplier. First start with the supplier. Where is supplier my? No, I didn't. Leipzig. Okay, supplier name is Leipzig. Okay, Leipzig, this is my supplier. To where? Supplier to 1 DC or all DC? That's why we need the group. That's why we need the group, all DCs. And then what is the our unit? Product and distance base, am I right? What is that cost? Product and distance base 1 USD per meter cubic. Product and distance base, and I am saying 1. Okay, I think we haven't defined the products. What are those 3 products? Okay, let me see. Products. So first product is monitor, am I right? Monitor, then PC, and then third one is MFP, multifunctional printers. Unit is meter cubic. No, unit is we are saying pieces. So tell me the price now. Monitor price first. What is the price of monitor? Monitor 850, and then price as cost, sorry, 250. What about the PC? 1150. And cost 350. MFP 700. There 200. Okay, this is done. Okay, then okay, let me see. Demand groups, paths. So here paths, I define that product and distance base. CO2 is not that. Currency, distance unit, transportation time they have given, am I right? Transportation time from supplier to DC, how much time they have given? 0.7 days or something. Look at the slides. Look. No, from supplier, the lead time from supplier to the distribution center is 0.7 days. 0.7 days, so that we need to mention here. 0.7 days. And then from what else? Next path is from DCs to what? All customer. Then product, and what is the cost? Same cost or different cost? Product distance base all customers, yeah, same. Okay, so DC to all customer, product and distance based, same, 1 USD per meter cubic. And then transportation time they have given in the which distribution? Triangular or something? Triangular. You select triangular. What is minimum? No, it's not 50. Something is wrong. So the lead time for the distribution center varies from 1.8 to 1.95 depending on the loading. So this is not a triangular one. Processing time, but this is a lead time I am talking about. I am talking about the lead time. So lead time is uniform distribution, 1.8 and 1.95. Uniform 1.8 and then 1.95. Done. Day. And what is this straight? Whether road, do you want to take the exact road route or not? I want to say, I don't want the straight route, whatever the exact route is there. Vehicle type, I haven't defined the vehicle type. Vehicle types. So first is the lorry, am I right? Lorry or truck? Truck. Truck. What is the capacity? Meter cubic, and speed is 50, am I right? And what is the lorry? 20 meter cubic. 50. Okay, done. Okay, come back here. Paths. Okay, so from supplier to your DC truck, and then from DC to lorry, less than truckload policy, and there is a no minimum load requirement here. Done. So our path table is completed, where we define the transportation cost. Now period groups. So period, I don't need period groups. Period, I am running for 1 year, 1st of January to the 31st of. Processing cost, now we need to add the processing cost. Processing cost of where? All DCs or one DC? All DCs. And then this is for all products, outbound shipment. How much that cost? 0.01 USD per meter cubic, am I right? Okay, processing cost is the product flows. Then we need to define, this is the additional table in the network optimization. So what is the use of this table? Suppose you have got the restrictions, supply capacity, and you want to add that constraint, like this supplier supply maximum this much amount of products, then you can do that. Okay, so that or you want to say fixed quantity from supplier to DC, you can define it. So you can see here now. So from sources I am saying supplier, expand sources, destination is all DCs, expand destination. What happens if I turn on this one, turn off this expand destination? It will, because what I have selected here, I have selected the group, I didn't select the single DC. So you need to activate this button. Why? So that from that one supplier the products will go to the all DCs, and that constraint will apply to the all DCs. Expand DCs. Vehicle type is truck. Product, all products. Expand products. Minimum throughput. What is minimum throughput or maximum throughput? This is the thing I was talking about. Suppose how much supply capacity is there. Suppose that supplier supply only 100 products. You apply that, add 100 products here. Okay, or what is the maximum capacity? Maximum capacity you can add. Or suppose if you want to say fixed quantity from that supplier to the DC, you can define the fixed one. Currently I am not applying anything here, so I am saying that whatever demand is there, as per that supplier can send it. Product unit, again you can see meter cubic or pieces, I would say. Let me double check it. Product unit you don't need to define it. Okay, that's fine. Product unit. And then second table from DCs to all customers. all customer. Okay, I am removing this line. Then this is lorry. Okay, you don't need to define anything. Product flows done. Product groups, we don't need to group the product storages, where we are keeping the products, all DCs. Expand facilities, we are keeping all products. Initial stock is there, I think. Initial stock is, oh no, initial stock is not given. Production, do you need the production? We don't need. Products, sales batch, site state changes, suppliers, tariffs, unit conversion. Do you need the unit conversion? Yes, we need the unit conversion. Why? Because each unit is given in pieces and we want to convert into the what? Cubic. Yeah, meter cubic. That's why 0.1, 0.1. Okay, so that's the your uh, conversion. 0.1, 0.1. Okay, then units, vehicle types. Let me see if everything is good. Yeah, can you see the connection now? Now show me the connections in your model. At the moment we haven't added it. I will tell you after this one. In the simulation one we will add the capacity. Saurabh, do you want to take the break? Okay. Okay. So can you see this now? Zigzag. What is this? Sorry. Which table you didn't get it? Okay. 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 Wait. So look at here, guys. This is the your actual route. Show connections. Can you see? This is the exact road they are taking. And if you see the straight connections, this is the straight connections. So for aeroplane, all those things, you can use the straight connection. But for exact one, you can do this one. And if you want to add, if you want to see the labels, you can activate the labels as where you can do the factories. You can filter as well. Suppose if you want to filter something, so that's done. How many of you completed it? Tell me. Raise your hand. One. Only one. Venkat, what happened? Tables. Yeah. See, there is no problem. There is no need of grouping as well. But if you don't do the group, so I will tell you what happens. Suppose you haven't done the grouping. So here basically you need to add 4 5 rows. For each DC to each customer you need to link that one. So the benefit of grouping, you can directly group that one supplier to DC, that group. So you don't need to add additional basically tables. Let me, okay, so now we will add some dashboard. Okay, so we are interested in product flows, then demand fulfillment and objective members. Okay, so now I want to create the dashboard. Okay, so I am clicking here. Okay, network optimization. So look at here. So already, okay, product flows are there. Okay, so already product flows and all those things are there. Network optimization, first option, select demand variation type, exact demand, and you have got these two options. What are these two options? 100 and 105, 95 and 100. Suppose if you want to consider the exact demand, whatever we have given in the table, select this one. But if you want to see what happens, your demand varies from 95% to 100%, then you select this one. Then the model will vary the demand whatever as per the given demand from 95 to 100, and it will run the model. But at the moment I am saying exact demand. Select search type. What do you want? Find best solution or solution of pool? I want find top 5 10 answers. Then number of best solutions to find, I want 10. And then solution optimization time 600. MIP gap is this one. Number of threads to use. Problem definition type big M. Statistics USD, product statistics meter cubic, and distance statistics kilometer. Let's see what happens. Okay, so duplicated name DC Prague and DC Berlin. Where did we did the mistake? Okay, grouping wise, because what happened? Okay, so I'm saying one. same name we have used, that's why it is giving the problem. Valid. Okay, let me run it now. So our model has completed the iterations. Okay. Okay, sorry, I think I didn't do anything here. Okay. Okay. Mm, okay. So here are the some options we have obtained here. So we consider three DCs. So this is our best results. So iteration 1, when you consider the existing DCs, DC Prague and Berlin. So this is the net profit, flows amount, total objective cost and demand fulfillment. So our profit is around 62 million. This is the considering existing 2 DCs. But if you want to consider all through 3 DCs, the third option, profit is 61 million. If your focus is on only profit, you would go with this one, and then it will show you the connections as well. Let me see if I can show you the connection. Okay, where is that option? Show. Okay, you can see. So this is the optimized solution. Okay, so profit is, when considering the existing 2 DCs, 62 million. Suppose if you want to consider only DC Berlin, look at this one. Can you see this one? When you select only one DC, your profit is 61 million. But suppose if you want to select the 3 DCs, then DC Prague, Berlin and DC Warsaw, 61 point. Let me tell me in which case you go with the third solution, and in which case you go with the first solution. If your focus is on cost, profit, you would go with the first one. But there is a benefit of third solution. What is that benefit? What is that benefit of third solution? What happens if you have multiple supply, multiple DCs and only 2 DCs? What is the benefit of responsiveness? What else? Transportation cost. Okay, that's all related to the profit. But what about the unexpected event? Suppose you have got only 2 DCs, something happened there, and those 2 DCs cannot supply, you, or one of the DCs is affected. Then multi supplier or multi DC means, if you have a problem with your existing DC, you can go with the additional DC. So if your focus is on those disruption risk minimization or something, you can go with the third option. So similarly, you can see other basically options here, and then accordingly you can select one. Then one important thing I wanted to show you, so product flows. So product flows, you can see this table. In the product flows, then you will see this is our Leipzig, this is our supplier. So from that supplier, DC Prague, how much quantity we have moved? 18,300 pieces. You can see all the DC Berlin and all those things. Now I want to see whether we have satisfied the demand or not. Okay, so go to the demand fulfillment table. Okay, and see what is the demand. Excuse me. Okay, look at the percentage. Can you see here? Demand received, demand minimum maximum satisfied. We have managed to satisfy all the demand. So demand satisfaction is 100. So then objective members, if you want to see the objective function, production cost is 0. Why production cost is 0? We are not producing anything. CO2 emission is 0. Okay. Storage cost, outbound processing cost is there. Okay. Revenue, transportation, supply cost, fixed cost, and inbound processing cost, and so on. So if you look at the slides, so in the slides you can see these are the KPIs we consider. Okay. So what should happen? The profits of product storages, minimum stock was set to 5,000 and maximum stock was set to 10,000 with the stock up penalties and stock out down penalties of 100 respectively. Now you could do one thing. Suppose if you go to this model and let me show you. So we want to restrict now product storages, minimum stock, maximum. Okay, 5,000. So I want to go to the product storages. I am restricting some constants now. Product storages, initially I said minimum maximum 0. I am saying 5,000 minimum, max stock is 10,000, and okay, penalty should be there. Under stock penalty is 100 USD and overstock penalty is 100. Let me check if does it make any difference. Okay. Okay, so maximum stock should be 10,000. Okay, valid. Run it. What happens, guys, if you restrict the distribution center capacity? We may not satisfy all the demands. So that's the thing may happen. Profit, can you see? Profit is down here 2.98%. Why? Because we restricted the distribution center's capacity. So then you may see in the demand fulfillment table there might be some problems with the demand. Okay, so this you can see some demands for the Vienna, Munich, Hanover, we couldn't satisfy that demand. Satisfied, can you see 000? So that's because of your this additional capacity. Now what I want to do, we will constrain the maximum quantity which can be delivered from any DC to any customer is 15,000 units. It is also possible to set up further constraints such as minimum throughput, as I said, maximum, and so on. So now we are talking about network capacited network optimization. Initially we didn't apply any quantity. Now we are saying that quantity delivered from any DC to any customer, it is 15,000. Okay, so let me try that as well. So this is my model. Okay, so I am saying the product flow, I am going into the product flows, any DC to all customers. So I am saying that that quantity should be below 15,000. Okay, let me check it. Then profit is again down to 2.66% compared with the result 2. Okay, so here you can again see the demand fulfillment table, and then you can see we may not supply. Okay, look at here, demand is 18,300 and we have satisfied only 15,000. Why? Because we restricted that the movement quantity from supplier to the DC to the customers. So that's the reason there. Okay, then now what we want to do, now we want to do the simulation experiment. Okay, so we want to convert this network optimization into simulation. and we want to add some inventory policies there, because if you look at the initial data, inventory policy is there for the DCs. Okay, so sourcing policy is there, DC capacity is there, so here you add that DC capacity 100 meter cubic, inventory cost is there, processing time is there. So now we are going to do that here. Okay, so let me, you can convert this scenario, convert this one into the simulation. Okay, network distribution network, convert, sorry, did I convert into network? Sorry, I wanted to convert into the simulation. Let me see. Okay, yeah, I converted into the simulation. So here is our simulation model. You can see the network now connections. Now you need to add couple of things here. So inventory policies, inventory policies here, can you see minimax policy, all products? So the data is given. What is that minimax policy? Tell me how much minimum? Yes, 57 and max 113. And then what is the initial stock? Is anything given? 40 is given. Okay, this is done. Then what else? Tell me next. Sourcing policy, closest fixed source. So sourcing policy, sourcing. So from Leipzig supplier to DC, all products. So we are saying closest fixed source. Am I right? For both cases, closest fixed source, closest fixed source, closest fixed source. Yes, customer TC flag. Okay. Okay. So here instead of what they did, sources DC Berlin and customers Berlin, added another one DC Prague, and then customers Prague. Okay, I am importing the scenario directly. So this is my existing network. 2 DCs, we are considering only 2 DCs. Why we are considering only 2 DCs? Why we are not considering third DCs? Because it is not adding any profit. So that's why we are excluding the third DCs and we are considering only 2 DCs. Now we have added some additional parameters here. What are those parameters? Customers are same. Okay, customers are same, DCs and factories 2 DCs, and we have added the capacity 100. Demand same. Okay, there is no demand. Expected lead time is 2 days. Okay, facility expenses, carrying cost is added. Groups inventory 53 plus 105. No, this is not correct. So this is the, okay, let me see. What was initially 53, 57? Am I right? 57 and 113. 113. And then initial stock was 40, or let me see, something is missing. So yeah, so sorry, the initial stock is 57. Okay, locations done. Paths, we have defined the paths here. The same uniform distribution, periods, processing time, products, shipping, truck, lorry, then less than truckload, first come first out, then DC Berlin to customers, closest fixed source, supplier is there, unit conversion, vehicles. Check, done. Okay, now let's run the model. what problems did you face, guys, in this model? Tell me so that I can focus on that thing. What is the? It was very fast. Uh, it, hmm, hmm. Okay. So basically, the complicated thing is, see, the locations, the latitude, longitude. If you know the coordinates, then 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 it won't be any problem. That's the important bit. You can see now. Can you see small products are moving here, vehicles? So this, it means that your model is running now, and you can see that. You can make it fast as well if you want. So this is my simulation experiment with that additional inventory policy. So this is my profit, okay, more than 60 million. This is my revenue, this is my total cost, this is my transportation cost, okay. So then ELT service level. What is this service level? Expected lead time service level. It means that we are sending some orders delayed, okay, some orders got delayed, so that's why service level is not 100%. We can check that. And this is the maximum lead time. Maximum lead time is more than 11 days. Then operational performance, peak capacity of DCs, you can see 65. Inventory and capacity dynamics, okay. Suppose I want to see, let me see, okay, peak capacity, available inventory, backlog I can see, okay. Demand backlogs, service level dropped to less than 100%. It means that, look at here, total orders received, fulfillment received, orders by customer, total orders received from customers are 2189. Out of that orders, we have managed to supply the 1830 orders on time and 376 orders late, delayed. Why? Because lead time was very short. What was that lead time? 2 days. We did not have sufficient stock. That's why this happened. Now, what you can do is 5 minutes. Five. Okay, okay, yeah, yeah. Mhm. Okay. So now tell me, how do we manage that delayed order deliveries orders? If you want to send them those orders on time, what could we do? Increase the what? Tell me. We have got 376 late orders. We want to what? What? Tell me. 376 orders got delayed. Can you ask the customers to increase the lead time? No, no, we can't. We, sorry, yeah, go on. Mhm. Truck count. Okay, so you can add additional trucks, and then we could do. Okay, is there anything you can do apart from that fleet management? Hmm? Penalty. Okay, that we could do. We could add the penalty, but basically, anyhow, they don't have the sufficient stock. The penalty will come, and penalty will be added into the objective function. The thing is that what you can do basically, storage capacity. So the capacity, when you increase the capacity, so it will try to satisfy the demand on time. Okay. So you can see here the profit revenue is 98 million. You can see that revenue here. Yes, 98 million. Can you see? This is the revenue, 98 million. Then your profit is 63 million. Profit is 63 million. Lead time I have shown you 11 days, and there are no backlog orders customer have placed. Okay, 13 were fulfilled on time, and 376 were delayed. Okay. So now what is the next step? Less than truckload policy is there. You can make it, you can add some additional, you can what you said, add additional trucks. Otherwise you can do one thing as well. You can reduce the capacity of that vehicle, so that small vehicle will transport those products. So now the team Davis, Marin and Cheng, they did some analysis, and what they found that the lead time variation was from 1.7 to 1.95 days, and their standard deviation was 1.125 days. So they tried to fix that inventory level. What? Safety stock equal to Z into lead time of standard deviation of lead time daily demand. So this is the formula they used, and they tried to find out the safety stock. Safety stock is 8 units, daily demand is 50, safety stock is 8. What would be your minimum level? 50 plus 8, 58. So what they did, they come to the conclusion that 57 is the good reorder point. But what they did, Marina now suggests that they reduce the stock further. She has noticed demand is always close to the average 90%, so they reduce the reordering point to 53. So this is their new reordering point, 53, and maximum quantity 105. So they are gonna change the now that inventory level. Okay, so from existing 57 they come to the 50, and then maximum inventory level they are also changing. So let's see now, we will do that change here. So in inventory I am saying, so 50, and what is the maximum level they are saying? See decide, oh, 53 and 105, 53 and 105, 05. Or we can do here as well, you don't need to go there. Profit increased little bit. Let's see what happened to the demand. Demand is still 376. Okay, 63.6. Okay, so this is your initial supply chain. New inventory policy we have included, but still our customer delayed order are 376. Profit went up little bit. Maximum capacity usage in the supply chain is 63. Now they want to reduce the they want to change the transportation policy. So what they want to do, instead of those big trucks from the distribution center to the from distribution center to the customers, they want to make some changes there. The paths table will allow you to set FTL or LTL policies. Okay, so what they did, they changed the transportation policies. So what they are saying, they replace the lorries that have capacity of 20 meter cubic with lorries that have capacity of 7 meter cubic, and this would reduce the transportation cost from 1 USD for kilometer to 0.5 per kilometer. Okay, and after they change the lead time from distribution center to the, so three changes: vehicle and transportation cost, and then third one is the lead time. So let's go to the our model, and then what is the vehicle types. What happens if you reduce the vehicle capacity here? Demand is 50 products per day. If you convert into the volume, because the lorry's capacity is higher than the, if you combine all three three products, so that's why they are trying to reduce the capacity of that lorry, so that it will help them to reduce the transportation cost, FTL policy. So they are making it to the 7. Okay, 7, and then transportation cost will also change into the path. From DC to all customers, it will get reduced to 0 point, sorry, 5, and then the lead time from disturbance into 0.7 to 0.9. The rest of the things will remain same. Look at here now, ELT service level 100%. Let's see what happened with our back orders. Look at here, order received 216, order satisfied on time 216. It means that we have successfully managed to recover from that delayed orders. Okay, so this is your uh, results basically. Sorry. Initial supply chain, then new inventory policy, we change the inventory policy minimax level, then new transportation policy, and lead time, they changed the lead time as well. So you can see that in these cases 376 orders were delayed, but here all the orders delayed order disappeared. You can see the inventory capacity, revenue, profit is there. Profit, in which case profit is maximum, this one, third one. Okay, so when what did you learn from this one, guys? When you had some problems like backlog, overstocking, understocking, or this kind of delayed orders, then you need to play with your policies, sourcing policies, your inventory policies, transportation policies, and you need to make some changes there so that your total performance will be improved. Lead time change, again they changed the lead time from 2 days to 1 days, because initially the customers lead time was 2 days, then they did 1 days, and expected lead time got changed. And this is the further benefits when the lead time for customer made 1. What happened basically in the existing case, this one, there were no customer delayed orders. So then the team thought that, okay, what happens suppose if you reduce the customer lead time? Then they reduce the customer's lead time by 1 day, and then they increase their profit again 66 million. Key factors in supply chain design, so again production cost, use of available resources, core competencies, cost restructuring, time to market, so many things. Single sourcing and dual sourcing, what are the some pros and cons of single sourcing and dual sourcing? Tell me. Less risk, in which case? Multiple sourcing. Okay. And what about single sourcing? Setup cost will be less. It is easy to manage with the single supplier, the transaction cost, operation cost, long term agreements ensure supplier reliability, price stability is there, early supplier involvement, you can involve in the strategic decisions, lower transactional cost because you have got only one supplier, supply chain effects. There are some disadvantages, higher risk. Why? Because I told you I think 2 days before how Sony becomes Sony Ericsson. That is the case. Because of only one supplier, Sony Ericsson lost the 400 million USD in during 2000, and then Sony Ericsson merged with the Sony, and it became the Sony Ericsson. Very classic and famous case study of single sourcing and dual sourcing. You can search on Google as well, how Sony became Sony Ericsson, then you will find the details. There was only because of the lightning, whole Philips plant in the New Mexico affected. Millions of chips were lost in that incident. Global sourcing, cost factors, quality service. Challenges in global sourcing like higher effort, time for travel. So tell me, during COVID, we are talking about local sourcing, global sourcing. So then do you go with the global sourcing or local sourcing? What do you do? Suppose if you join in any company as a logistics manager or as a procurement manager, what do you prefer? Do you prefer the local source supplier or global supplier? Local. Okay, good. Do you think that you will get the good price from the local supplier? What are some of the problems from the local supplier? Why do you think that all these big companies from the western world, They have the suppliers located in Asian countries, Bangladesh, India, China, Japan. Why? Cheap labor. Okay. So basically, so you are saying that we should go with the local supplier every time. Am I right? And then which case? Local supplier. What are the benefits of your mix of balance of local and global suppliers? Hmm. Yeah, and the best example is COVID-19. So during COVID-19, everybody was talking about local supplier, local. Why? Because their global suppliers were affected. That's why they were talking about the local suppliers. But when you go to the local suppliers, sometimes they give you the higher prices. Suppose here the labors, they are not that much expensive. But if you look at the Western countries, labors, all those things, they are very expensive. That's why they come here, and then they take the raw material components from the developing countries. So the key takeaways from this single sourcing, global sourcing is that mix of global and local suppliers, so that suppose there is a problem from one supplier, you can go with your backup supplier, local suppliers, and you can run your the operations. But during COVID, what happened? Most of the companies, they were dependent on the suppliers in China, other parts of the world. When then lockdown, border closure happened, initially somehow for 15 days or 20 days they managed with their backup, the safety stock and all those things. But after 2-3 weeks, everybody was facing the shortages, and some plants they closed as well. So because everybody was going to the local suppliers, and the same thing happened in that Nokia Ericsson case as well. I will briefly explain it. What happened basically, in March 2000, Nokia and Ericsson. Nokia had a multi-supplier strategy. They had for these semiconductor chips, they had multi-supplier strategy. And during the 2000, the cell phone production was in the boom, and there was huge demand. And Nokia and Ericsson were the two biggest players in the telecommunication industry at that time. Nokia had a multi-supplier strategy for the semiconductor chips. Their main supplier was Philips, but they had some additional suppliers. Ericsson's, if you look at, Ericsson was from Finland, not Finland, from Sweden. So Ericsson had single supply strategy. They were totally dependent on the Philips for the semiconductor chips. So in on March 17, 2000, their Philips plant from New Mexico, because of the lightning, fire happened into that plant. Okay, and then fire, they managed to stop the fire in 10 minutes only. But what happened after that, it was very drastic. Because do you know how do we make those semiconductor chips? Does anybody has any idea? How do these companies they make these semiconductor chips? If you look at the room where they make the semiconductor chips, that is 10,000 times cleaner than your operation theater in the hospital. Not a single dust should go into that semiconductor chip. Okay, it will spoil the whole lot. So when the Philips, they managed to stop that fire in 10 minutes, and they turn on the sprinkler, smoke was there, all that smoke, everything, it went into their storage room. And in their storage room, thousands of chips, ready-made chips, those who were ready for the shipments, they kept their thousands of chips. And this smoke entered into their storage room, and it spoiled all those thousands of chips. Okay, and then Nokia had a proactive approach of managing the unexpected events. Nokia used to get the regular updates from the Philips. Okay, so how did they identify this problem? They couldn't get the update, the chips to the Nokia, and their procurement manager, they found quality. Then after 2 days, he informed to his senior manager, we couldn't get the updates from. So initially, Philips thought that this is a minor incident, we could recover in 1 week. It was very significant. They couldn't recover, like it took almost 1.5 months or 2 months. Ericsson's, nobody was aware of what happened. They thought that okay, ground level, it was they were talking about, yeah, it happened. Nokia had taken the proactive approach. They went to the Philips and they said, you do one thing, you have got other plants, you supply the products from the other plants, then they to capture the additional supply. They changed their cell phone design, everything. 1 or 2 3 weeks so they were waiting for Philips on them, and then they would decide how to deal with that one. But after 2 3 weeks, when market to find out the additional supplier, everything was captured by the Nokia. 400 million, 400 million USD, and then finally, then Sony has taken very classic and famous case study of what happened when you depend on the single supplier. 15 minutes break, and I have got another very interesting case study, smartphone supply chain, because I talked about. So this is global supply chain. We have got the air freight, sea freight, road freight, everything. And today, Saurav, I think we are 1 hour will be there after the tea break. Okay. So do you want to wait or? Okay. Okay. Meanwhile, I have to stay here. I have a habit of moving from one point of. Any doubts? Any questions? You were asking something about that. What were you asking? You can bring your laptop here now. If you have any problem with the model, if you didn't get it, you can ask me. Okay. So this inventory. Inventory table you don't need to define here. Storage, storages, product storage, product storages. That is the inventory. Like you have defined everything here. So inventory will come into the simulation. I don't know.